This video is a quick overview of how to configure the Palette 2S Pro to work with a Klipper printer. In order for this to work, you will need access to the SSH connection to your printer, or at least be able to access the main cell main GUI on your printer. If you are using the Palette 2S Pro using the Octoprint configuration, this video does not apply to you. This is only if you would like to connect the Palette 2S Pro directly to your Klipper printer and run it in accessory mode with that Klipper printer. So the first step is accessing your main cell configuration in Octoprint. In Orca Slicer, rather, I already have my device configured. There are multiple videos that show you how to do this, but I want to keep this short. Go to your printer configuration file, which is under the machine section. And what you want to do is essentially add the Palette 2 Pro section that I pasted on the other page, and you can see it right here. Now, what this code does is it essentially connects to the Palette Pro immediately upon your printer starting. So this is assuming that when you turn on your printer, the Palette Pro is already connected to the USB port and powered on, because the printer will automatically connect to it. One thing that you want to do is update the serial address, the device serial address for the Palette Pro. I added steps to do this on the other page, but just to kind of walk you through how to do it. One of the easiest ways to do it is to just go to the Devices tab up here while the Palette Pro is connected to your laptop or to your Raspberry Pi or whatever computer is running Klipper on your 3D printer. So go here to the Devices tab, and under the Serial tab here, hit the refresh button if you don't see anything. But you should see a list of USB device paths here. What you want is the path by ID. Usually it'll only list your Palette Pro. So go ahead and copy that. And that is what you want to paste in this section here. Alternatively, you can SSH directly into your main Klipper computer and run the Linux command for listing devices by serial devices by ID, and you will get a list of devices as well. A similar ID will be listed in there. There's plenty of videos on this, so I will not bore you on that topic. The next thing that you need to do is just go through the code here for a second. Particularly pay attention to the G-code macro M104. This is set up such that all of the temperature readings that are unique to each input on the Palette Pro are all mapped to one nozzle. So this is assuming your computer only has one extruder with one heater, and you are connecting the Palette Pro output to this nozzle, to this extruder. So all the temperature readings will be remapped to this extruder. However, the temperature will go up and down based off the material that is about to be loaded. If your computer or your 3D printer rather has an extruder with a cooling fan on it, my 3D printer does not have this cooling fan, and therefore I did not have to account for that in the G-code macro section here. But you would need to write a similar macro for fan speed G-code to essentially take the fan speed that's coming in and then map it to the extruder main fan in case the material about to be loaded needs to be cooled or does not need to be cooled. You can just copy this G code here, change this to the proper G code for fan cooling, update the description. Again, change that same value up here. The 104 value is a different value for fan speed. And you can go ahead and just remove the prefix from the fan speed value in the G code and set whatever letter that is preceded by the fan speed G code, and this code should work generally speaking. You will also need to go ahead and update the set heater temperature call here. This is a Klipper specific call. What you want to do is set the extruder fan speed instead, which you can find in the Klipper reference documents online, what it actually is called. Essentially remapping all of the fan speed commands to the main extruder fan speed. And that's about it. You can leave all of the other G-code macros here. They don't really play into your configuration as much, so just keep everything else the same, and that's really the only thing that you will need to change if you have a cooling fan on your 3D printer. After you have gone ahead and updated your printer.config file, save and restart the printer. In my case, I'll simply close it, simply because I've already saved it on my computer. And let's go ahead and configure the slicer. So as you see, I'm using Orca Slicer. And if you have a modified 3D printer or a stock one, regardless, you will still need to make this modification in your slicer. The first thing is to go to your printer configuration in the slicer. Under basic information, obviously you can configure your printer like you normally would. If you already have this setting configured, there's really nothing here for you to change. Next, go to the machine G-code section and make sure you've adjusted your machine G codes accordingly. Do not copy my codes here. These are unique to my 3D printer. Normally there's nothing in here for you to change to begin with. What is important for this Klipper configuration is the multi-material section. So here you want to make sure you set the extruders to 4, disable all of the other settings, and set everything else to 0. Now, once you add additional extruders, you'll see that you have multiple extruder sections in your slicer profile. And you can go in each section to set the values as shown. You set your retraction speed accordingly. What you want to do is make sure that the values of each extruder are identical. So everything that you defined in extruder 1 section should be the same in extruder 2, extruder 3, extruder 4, and so forth. That's it for the slicer configuration. So we'll go ahead and just save or exit out of here. And go back to the slicer. When it comes to using multiple materials or multiple colors, you can simply go ahead and configure multiple materials. Now, since we have multiple extruders on this machine with using the Palette 2S Pro, each filament setting that you assign here, for example, the nozzle print temperature, will be unique to that material. So if you choose PLA for tool 1, or has the one assigned to tool 1 in your slicer, and you set a temperature of 210, and then you go and set ABS, for example, has the material to be used in tool number 2, the temperature for that ABS will be transferred to the G code. And so what will happen during printing is when the palette slices ABS, your extruder will start heating up to 260 degrees Celsius and so forth. So that's accounted for in the printer config. The translation happens at the printer configuration level in Klipper. So that's just a little explanation of how to configure your materials there. The rest of settings here are just as you would handle any other material. You have the quality, speed, support, and so forth. You can choose whatever material is assigned to a particular object and tune your processes accordingly. The key thing is to make sure that you set up your extruders and you set the values amongst those extruders identically to one another. And that's it. You can see here I've loaded a multi color model, a multi-material model, assign them different colors. And the proper way to now print this with the Palette 2 S Pro and a Klipper printer is to slice the plates. So you basically slice the plate. Once the plate is sliced, you can go ahead and it looks just like any other material, multi-material configuration that you've sliced in the past. And this is thanks to the Make Anything group. They're the ones that created the materials here, the objects here. Those are not my models. So give them credit where credit is due. And next you want to export the G-code file. So when you select that option, go ahead and click Export G-code file, and to generate the G-code file from the slicer that will then be imported into Chroma. So we'll go ahead and name this file. Let's give it, let's leave it named Make Anything Logo just for simplicity. And I'm going to save that into a directory. Just remember where you save it. In this case, palette stuff, for example. Once the file is exported, we can go ahead and go to Chroma, which is a software that is offered by Mosaic. You can either use Chroma or you can use their online tool, which is called Canvas. The process is the same. The only difference is Chroma runs locally on your laptop, whereas Canvas is online and you have to upload your G-code to the Mosaic webpage to follow this process. The process I'll show you is just to use Chroma. Again, it's the same steps, just different applications. Once you have Chroma configured, you want to go ahead and create a printer profile. You'll see here that I already have one for my custom ender, but for your printer, you can go ahead and go to Profiles, Printer Profiles, and click on New Profile. You can either follow the guided or manual setup. Manual setup basically means do you want to choose a printer that already exists on the market, like the Ender 6, for example, and it'll define the print area for you and all the other options for you. Or you can go to manual setup if you have a custom built printer and enter the print dimensions yourself, the print volume yourself, and for that purpose. So if I edit my current printer configuration here, you'll see that you'll ask for the nozzle size. The number of extruders should be set to 1 because you physically only have one extruder on your printer. And what Chroma will do is it will read the tool change G codes from your slicer, like the T0, T1, T2, and T3, and it'll use that to understand when to change colors, to tell the palette to change colors or change materials or splice materials rather. So what's happening here is for your printer configuration, you are simply specifying what nozzle diameter you're using, the number of extruders. Again, the nozzle diameter should be the same thing that you use in your slicer. The number of extruders here should be 1. In your slicer, it should be 4. And in the firmware option here, we're not going to choose anything unless your firmware is a custom firmware and you're using one of these printers from these manufacturers. Normally, Marlin tends to work with a lot of printers, and that's the firmware flavor that I selected here. And obviously enable some of these options if your printer uses those. My printer does not. You want to set the firmware purge to 0 at the beginning, disable purging in your printer, and you can always configure that in the future. The input file is going to be a .g code file, like we just exported here, the make anything logo.g code file, because we'll import that into Chroma shortly. Post-processing, we don't really want any post-processing unless, again, you're using a printer that requires this. We're using a Klipper printer, so we do not want any post-processing. The code is already generated to work with Klipper from the slicer. So just leave these settings as is for the most part. The other thing is on the dimensions. You can, as I said, you can go ahead and manually define dimensions, or again, if you followed the guided wizard, it would have set these for you depending on whether your printer is a stock printer or an aftermarket printer. If you're using an aftermarket printer that you built yourself, just go ahead and use the manual option and come in and set these settings yourself. My printer has a direct drive extruder, so make sure you disable this option if yours does as well. But if yours has a Bowden tube, you may want to set the length of the Bowden tube here. The palette option, I'm using a Palette 2S Pro, and it's in accessory mode. Connected mode only should be enabled if you're using this with Octoprint, again, which does not apply to this video. So just leave it on accessory mode. Ping retractions are left to auto, and everything else you see on screen here. For transitions, you have a couple of options. I personally print very large models, so I typically let the purging happen inside the models. But if you would like to have the transition happen on the side of the bed, or maybe purge into a purge bucket, you can choose one of these two options here. And Chroma will essentially take your G code and modify it so it will add the side transition towers or side transition rectangle. And then it'll enable all of these options here so you can tune your side transition. I don't use any of this, so again, just choose don't purge transitions and then just say it's safe. Then you need to configure your materials if you're using those that are not specified here. So by default, the Palette 2 Pro S comes with the Splice Core S Pro, and you can go ahead and just choose the default defined materials here. But if you have a custom material or you would like to add a new one, you could just hit on New Profile, choose whatever you want, and give it a profile name. Now, what you really are doing here is you're telling Palette, hey, when you're cutting and welding this material to another material, here the heat factor, compression factor, and cooling factor settings used. Heat factor basically just means you want the palette to heat the material a lot more so it bonds well to the other material that it's being bonded to during printing. Again, this is for the filament to filament bonding, not your print temperature. The compression factor here, again, how much does the palette squish the two materials while it's bonding them? And the cooling factor is how long does the palette cool the welding after it's done welding them together. Then you can hit the create button here, or you can just choose from the drop down list again, select some materials that are already predefined. here. You have soluble materials, flexible, TPU, you name it, they have it. So I'm not going to save this, but in your case, you would. And then that's really it for configuration. Now, as part of your workflow, what you'll do is the next time you come around here, your printer profile will already be defined. So there's really no additional configuration for you to do. That was a one-time thing, unless you're tuning things, right? And so during part of your day-to-day workflow, you basically go to your slicer, you load the multiple, you load and slice your parts, you export the G code, you open Chroma, and then you click on load print. Now in Chroma, once you click load print, it'll open up the Windows Explorer dialog for you to select that G code file we generated from the slicer earlier. Go ahead and click on open, and it'll analyze that G code file and pick up the number of colors in there. You don't have to use all 4 colors all the time or all 4 materials all the time. You can use one only, or one in all 4 slots, or only 2, or only 3. It'll pick up on all of that when you generate the G code. So the important thing to do here is to make sure that your inputs are properly assigned. For example, if I look at the back window here, you can see that my blue color is assigned to extruder number 1, meaning that if you look at the Palette Pro from left to right, you have input 1, 2, 3, and 4. So when you G code says extruder number 1, that is extruder number 1 in the Chroma application, the one on all the way to the left. So you can expand that, choose your material to assign to that input, and then choose whether you want to just represent it in the viewfinder here using a different color. So you can go ahead and choose different colors. I'm just going to leave them as default. Again, you could change different materials for each input. And when the slicer is, when the palette is slicing G code, it will go ahead and load the heating profiles for these automatically. Meaning, it'll, if it needs to heat up 2 materials a lot more to bond them, it'll do that based off of your material configuration here. So once you've defined the color mapping here, again, extruder 1 is all the way on the left, extruder 4, I should say input 1 rather, on the palette is all the way on the left, input 4 is all the way to the right, so pay attention to that. And when you've done configuring your materials or colors, again, the printer doesn't really care. The colors are different materials as far as the printer is concerned. So you could load ABS, TPU, PLA on each of these inputs here. Just make sure you configure the temperature setting accordingly in your slicer. Now, once you're done doing this, again, you can go ahead and choose printer profile here. If you wanted to automatically generate that side transition, you can go ahead and use a transition tower, for example, hit save, and then when the change is generated, you hit the regenerate button, and you can see it generated a transition tower here, and that's where it'll do the color change. So that's an option if that matters to you, if you would like to get more accurate color changes. Go ahead and hit save for printer. And when the save for printer option will show the Windows Explorer dialog, where you can go ahead and export the configuration files. So since we're in accessory mode, 2 files are going to be generated. One that you will save on the SD card that the palette comes with, and you will put that SD card in the palette when it's time to print. And the other you will load into the Klipper printer, either via your main cell interface or whatever you use to send print jobs to your Klipper printer. So go ahead and hit the save button. And when the Chroma application is done generating these two files, you'll see that there's one .maf file that has been created and a .maf.gcode file that has been created, and it tells you to put one on your printer and the other on the palette SD card. It also gives you a summary of the number of splices the palette will do. So in this case, it's about 24 cuts and welding that it'll do. And go ahead and hit the close button, or you can just hit the Show Explorer button here, and it'll open up Windows Explorer to show you the files. So you can see here, there's the original G-code file that we generated from the slicer. We will not be using this. There's a text file that the Chroma application generates, kind of like a summary of your slice settings. It's an option you can enable. You can also disable this in Chroma if you don't need this. Don't really use it. The only two files that you will need are the .maf file and the .maf.gcode file with the same names. And as the Chroma application is done, we can go ahead and close this. So from here on, you just go ahead and drag the .gcode file to your Klipper printer, or you can put it on a USB card if that's how your printer is configured. Just copy this file to your printer like you would any other regular G-code file that it needs to print. Then copy the .maf file to the SD card that comes with the Palette Pro. So just take it out. There's a little SD card to USB adapter that comes in the box. Just put the SD card in that adapter, stick it into the computer, and then copy and paste this file onto it. And then put the SD card back into the Palette Pro. So now to start printing, what you will need to do is go on your Palette Pro, go to the Start Print menu, and then select the file, the Make Anything logo.maf that we copied to the SD card, because you may have multiple ones. Just make sure you pick the same one as the one you're about to launch on the printer. And when you click on this, if it's your first time running the Palette Pro, it'll ask you to go through the configuration process where it'll ask you to remove the output tube on the palette. It'll push out some material, and you'll need to load all four some filament. I would say about 60 inches of filament on each input, because it'll make you go through that process a few times as it calibrates itself. So just put the filament in inputs 1 through 4, follow the instructions to calibrate the Bowden tube length. And if you're using the PTFE adapter that comes in the box, or this that I made, you do need to make sure that when the palette asks you what size Bowden tube or what size PTFE tubing you have, that you enter the actual length from the end of the adapter. So basically the end that goes into the palette all the way to the end that attaches to your extruder. So that tube value, you can hit the custom button on the page where Palette asks you that, and you can enter the value. So pay attention to the units. They're not millimeters, they're centimeters. And then proceed with the rest of the configuration, where it'll ask you to pull out the tube, stick it in the extruder, and then run and heat up the extruder and start extruding until it senses that you've started extruding. So you don't need to run through that process every single time. It's only the first time you're calibrating your printer, but you will need to purge the output PTFE tubing after every print. That's just how the palette works. So once you've completed that process on the palette, it'll say, okay, you can start printing, and it'll start splicing material. And in the meantime, just go on your printer. When the palette says that it's ready to start printing, you can then go on your printer and then select that Make Anything logo file, that G code, and then hit the print button, and your printer will start printing. And what will happen is during printing, if the palette is not able to keep up, it'll pause your printer or it'll slow it down. You can choose this behavior. If you want, you can customize it in G-code as well, or in the Klipper configuration as well for the palette in the palette section. So just instead of using the pause command, you can add additional macros to do other things. Or you can also choose options in chroma so that it just moves your head back and forth, your extruder back and forth, and doesn't actually do any extruding. But there are different strategies around that. But at this point, your printer should be printing, and the Palette Pro should be slicing materials as it notices that it's about to run out of material. And that's pretty much it.